Okay, welcome everybody. Welcome to my talk, doing the DDD dance with Google Cloud. Everybody can hear me? Yeah, sure, great, excellent. Sorry, I had some startup problems. Forgive me. Yeah, let's start. With me, who am I? I'm Albert Brandt. I'm from CBA Software Development. And you can find me here, but you can connect after this presentation. Really go to Threads, not to X. It's better for you. So what I'm going to talk about? I'm going to talk about Google Cloud and domain-driven design. And let's first start with Google Cloud. Who is familiar with Google Cloud? Maybe can I see some hands? Yeah, lots of hands. Great. Well, yeah, I do need to tell the others a bit about Google Cloud, but probably you know it already. So Google Cloud is a suite of cloud services on a global network of data centers. It's from Google, of course. It comes with a lot of managed services, and yeah, you get everything. So everything that you want from a cloud platform. So you have compute, you have storage, you have of course machine learning and AI, Google Gemini, great. But you also have a great marketplace where you can buy systems or can yeah, get systems up and running in seconds for you. So that's a great start. I would say it's the better AWS, but some might have a different opinion. Okay, and domain-driven design. Who is a bit involved in domain-driven design? A little bit less hands. Yeah, so everybody who just raised their hands for Google Cloud and then raised their hands for domain-driven design, they can leave now, okay? No? Okay, okay, now just kidding. So domain-driven design is I would say a set of patterns that help you to build complex software systems. And it has been coined by Eric Evans 20 years ago. And yeah, it's from a completely different direction, I would say, than normal development. Eric Evans saw that software developers had a hard time getting implementations of the right thing, building the right thing. So he said we need patterns, and with patterns he meant we need something above the code, some strategy, some call it heuristics, to help to build better software. So yeah, he coined a lot of patterns. You could say that there are two kinds of patterns. You have the strategic ones, which are more about the architecture of your system. And then you have the tactical, and that is more about how to implement your system in the right way. And we will see shortly a couple of these, both strategic and tactical patterns. And then I will show you how you could implement those on Google Cloud. And hopefully we can see that there is a dance together there. So yeah, so what is the connection between domain-driven design and Google Cloud? Well, yeah, DDD or domain-driven design itself is pretty much technology and cloud agnostic. It's not entirely true, but if you look it up online, you will find lots of information on how to implement your system in any language that you want, based on the domain-driven design principles. And you will also find resources how to implement it on a cloud. So yeah, there's, I would say, not a hard connection, but of course, nowadays systems are built using cloud technology. Yeah, then there probably are some places where there are some things connected to each other. Yeah, so and Google Cloud, of course, is application agnostic. You can build anything on top of Google Cloud. That's great. But they don't really prescribe any way of building your app. They have several ways of running your system, and yeah, we'll see in a moment how you can do that. So yeah, they're both fit for both simple and complex things, and the DDD patterns are mostly used when things get rough, things get complex. There's a whole community around it that helps people understand why our software is our software is complex, and they even have different levels and all kinds of different ideas about the complexity and how you should respond to this complexity. So let's see if we can dance. Let's start with some strategic design patterns. By the way, for the people who are wondering right now, all the images in this presentation have been generated by AI, so no walls have been harmed during the making of this presentation. And I didn't have to scrub any walls afterwards. So a big pattern, or maybe the number one pattern that you will learn if you learn DDD, is the ubiquitous language. And what is the ubiquitous language? It is trying to define or develop a language that is spoken with the entire team, and not only with the entire team, but around a certain subdomain. And the whole idea is that this ubiquitous language will help you in defining the part of your software that you're developing. And not only the developers in the development team, but also other stakeholders, business owners, domain experts. Everybody should be talking the same language, because every time that there is something that there's something not entirely aligned with each other, then there's the chance that something will error. And this error will only lead to more complex situations. So it's good to define this ubiquitous language. And yeah, that's the main goal of this pattern is to get it on paper, or get it at least out of your heads and in other people's heads, or on paper, or in your cloud document system. Anything that you'll be using, you can use to write this ubiquitous language. And every word that is spoken is actually the ubiquitous language. We will see more about this. So here's an example of a domain. Let's say that you are a library organization, and you have an in-house team of developers, and you're trying to build software yourself. I'm not sure if that's the best idea for librarians. I hope I haven't offended anybody, but okay. So we have the development team, which is developing a piece for book lending software. So they want to register who is lending which book, and they will have a part of the software under control there. But then there's also an analytics team, because the library is pretty good in trying to recommend stuff, and they also saw that the development team doesn't want to be bothered with the recommendation. They don't see this as their core, so they have a different team that is more looking in which book is landed most, and maybe we should do who took this book is also interested in that book. And of course you have the financial team, and they are more in how can you get the money from the people who are lending the books, because in the end it's all about the money. But you can see that there are three different domains at play here, and the development team might be talking about the book lending process in a different way than the financial team. The financial team is not really interested in the books itself and in the members itself. It's only interested in, can I get some money from the users, from the lending, from the people who are lending books. And the analytics team might be more interested in books, but maybe less in users, or maybe only in the aggregation of all the of the amount of books being lended. So yeah, there are different roles here at play, and each team might have their own way of talking about the domain that they're looking into. And to prevent problems with trying to define a ubiquitous language is a key to getting the development team talking on the same page and building the right thing, and the analytics team can do something else. And you don't need to have a global model of everything. We've seen this in the past, some kind of a God domain model that encompasses everything in your organization. No, you should actually be focusing on smaller parts of your software, and you should have some consistency there via the ubiquitous language. Okay, and now for the bounded context, that's the next pattern. That actually creates clear boundaries across the business domain. And these clear boundaries are really helpful when you think from a software perspective, but also from a development perspective. You should be thinking about how does the analytics team get information from the software that the development team is writing. And that helps you to find the right boundaries of the ubiquitous language as well. And yeah, in the end, it defines the interfaces between the different bounded contexts. And often we talk about bounded context as a developer. Is this then something like a microservice? Or is this something like a service? No, it doesn't have to be. So this is more of a modeling of your domain concept. That's why it's a strategic design concept. So let's look at inside of our core domain, which is the lending software. There might be 3 different bounded contexts at play. Maybe the team is growing, and maybe at some point we have some people more working on the catalog, some other people on the memberships, and some people more on the borrowing part of the software. Then you can get into different bounded contexts. So it's not always the team boundary. It could also be the part, a subdomain of your core domain, of any of the domain. And the next pattern, last pattern I will mention is the context mapping. That is talking about the relationships between the different bounded contexts within the larger system. So how does these bounded contexts relate to each other? So you want to identify the integration points, but you also want to think about how is the information flow going, and you can strategize based on the elements, based on the interactions that the different boundaries have. So here you can see that the analytics team, for instance, is following for instance, the services that the core team is building for the catalog service. So in this case, the context mapping uses a word for this called conformist. And there are much more relationship types that you can find in the context mapping pattern. And these are helpful in defining the relations. So let's throw in a quote. It's obligatory, of course, to have a quote in your presentation. It's not the domain expert's knowledge, but the developer's assumption that of that knowledge that goes into production. This was my namesake, or sort of namesake, Alberto Brandolini, who is the person behind event storming, or the concept of event storming. And he made a really clear statement here that sometimes as a developer we are making assumptions about what should be in the software, but have we actually thought this through, and have we actually talked to all the right people? And it's concepts like like event storming that can help you define the domain better. So let's look into some tactical design patterns. And these get more into the developer level. I like the blob, by the way. So an entity. Again, the pattern does not state that it should be something of an entity like some people might know from object-oriented programming with an object relational entity. But it's about modeling an object that has attributes and some identity. That is an entity. And that can represent information in your domain that requires some tracking across various changes throughout the life cycle of this of the entire model. And it always has an identity. So if I have an identity and I find it in another place in the model, then things with the same identity, you can think of this as an ID from a database or a generated UUID. If we're talking about the same identity, then these two things represent the same thing. But they don't have to exactly have the same information inside of them. We have another technical design pattern, a value object. And here we have objects that are a measure, or they are a quantification of something in the domain. And often you have some aggregation of information in an object, but the attributes themselves define the identity. So if all the attributes are the same, and you have two different objects in memory, then they actually represent the same concept in real life. And for this, if your language or your environment supports it, you should use immutability. And if you change any of the attributes, you should get a new instance, or something like that. And then the final design pattern that's not the final. The third design pattern are aggregates. So the domain-driven design, a tactical pattern on aggregates is quite large and talks about how to create let's say a sort of a tree structure of entities and value objects that are clustering some information. And of course, each aggregate has a root. You could see this as a tree, and the root actually takes care of the consistency of the entire aggregate. So in memory, you can have a representation of information, but via the aggregate root, you do all the changes and you get all the information from the entire cluster. And of course, you can see here that the aggregate root should be the public, should have the public interface, and everything else of the model should be more private. Also, consistency is just one thing. If you look at persistence, then the aggregate root also is the place where the transactional consistency is coming in. And then the final pattern that I want to mention from the technical design is domain events. And this is because there's, of course, a link to asynchronous communication on Google Cloud. So domain events are occurrences that happen in your domain. And again, you can model your entire system on paper if you want to, using these patterns. You don't have to have a direct implementation for them. If you have some occurrences, if you have some time series events, then this is the way to go. And domain events are used to communicate between the parts of your system. Of course, you don't have to use asynchronous events all the time. You can also use synchronous invocation, etc. But yeah, it's good to think about: is this something that I want to model explicitly as an event, or is this just an API call, or is this just a function call inside of my system? And domain events have the benefit of triggering side effects without the rest of the system knowing. So it's a great start if you want to build loosely coupled systems. So if we want to apply these patterns on Google Cloud, let's first start with the technical patterns. The technical patterns, if you look at the implementation, of course, they will be materialized by implementing a service that encapsulates that part of your domain model. So again, there's not a hard relationship between the services that you build and the domain model that you're representing. So you have to you have to think about that a bit. Those domain models, of course, come with interfaces. So these interfaces and contracts, you have to design these, of course, at some point. And you want to separate some the domain logic from the infrastructure concerns. So Google Cloud comes, of course, with some infrastructure that you need, and you can use a pattern such as ports and adapters or hexagonal architecture to actually identify the infrastructure concerns in your code versus the domain logic. Looking at a domain model implementation, here you can see, maybe just look through your whiskers, there's a tree structure here. It all starts with an entity, which is also the aggregate root, which is the way to go to the catalog. And then there's an internal representation of the model, which might or not be good. But yeah, this is a way to represent it. You can do this on Google Cloud. You can use Compute Engine if you build your service on a really bare bones machine. You can run it on Compute Engine. You can just pull out any programming language that you like. If you have the appetite for it, you can choose Kubernetes. You can use App Engine. For people who do not know it, it's a managed service that takes your application code and is a very easy way to deploy your code. It doesn't have to be in a Docker container. It doesn't have to be containerized. You can use Cloud Functions, which is also a good way to take small pieces of your domain logic and then bring it to the cloud. You don't need a lot of infrastructure code in your Cloud Functions. And as last, you can, if you don't really know for sure what you need to do, just take it granted from me that Google Cloud Run is your the best and most modern solution on Google Cloud that you probably want to use. You can persist the data using different data storages, data storage services. Of course, please keep the services, keep the data from different services in their own data store. Please do this. This will help you tremendously later, because if you do not persist in different data stores, then at some point you will get the big ball of mud, but then your data storage. Also, data sharing, they should be a communication concern. So go via services to retrieve your domain data. And how can you implement it? You can use Google Cloud SQL for this, or Google Cloud Storage, which is just more of a flat file storage. You can use Google Firestore for, maybe people have already used this in the past. It's a great way of scaling a document database. Or if you really want to go really far, if your services need it, if you need planetary scale databases with horizontal scaling, then a Cloud Spanner is the way to go. They're also at Google, they're using this internally for analytics, and it's a great tool, but it's quite expensive. Then how could you do the interfaces integration? Yeah, you have to think about it. Are these RESTful APIs? Do you want to use gRPC? Do you want to use events? But one thing that you do need to do is version those APIs, because at some point there will be new versions, there will be conflicts. You want to make this robust from the start. And then, yeah, the integration solutions that you have on Google Cloud. You have Google Cloud PubSub, which is a managed messaging system. It's a great and easy fit. For instance, Google Cloud Functions and Google Cloud PubSub, they really are great together. And you can build your entire domain-driven design architect solution using only those two tools. You can also choose from an API gateway to make sure that all your components are well organized and that security and the logging and monitoring is in place. And another new concept is Google Cloud Endpoints, where you take your specification of the endpoints and you let Google Cloud work out everything up until the actual endpoint. So that's also a great solution. And now something about the strategic design patterns. Well, that ubiquitous language can also be applied inside of Google Cloud. So use it everywhere that you can. You can use it as part of naming conventions for resources in Google Cloud, and this will absolutely help you in the long run. And of course, you should be using it in your code base, and it's pretty helpful if you use tools to actually check whether you have used the right naming. You even have a whole niche tools set of niche tools to check if the language that is spoken in your code base and in your services is actually correct and is coming from the same language. And then the bounded context, yeah, well, separation of the separation concern. Yeah, looking at Google Cloud, you can split using virtual private networks, virtual private clouds, and you can lock down really good how services communicate using, for instance, Google Cloud endpoints. That's a great way. So it's all about the separation. So the harder you make it for information to flow free from one system to another, the better for your structure of your code. And context mapping, well, that can be used to be a strategic architect of your cloud architecture. So this helps you tremendously to define the form of your bounded context. Bounded contexts, and yeah, there's a lot to it, so please look this up and probably you will find something interesting there. And there's more to Google Cloud, but I'm completely out of time, so please optimize for performance and cost. Don't use microservices everywhere. Also consider even the monolith, but please then do it good and consider the modular monolith, because this can help you immensely driving down performance and cost. And there's a special cost management monitor for that. Of course, we have Google Cloud Deployment Manager, and we have the Google Cloud Build to build your app. And monitoring and logging, you get it almost for free. So use it, because else, if you don't do this, your next bug in production will look like a murder mystery on steroids to solve. And of course, security first. Luckily, Google Cloud is really secure and comes with the principle of least privilege. So that's great, but do think about it in your application. So my final verdict is, there's nothing stopping you from implementing a DDD architecture on Google Cloud. So let them do the dance together. I hope you enjoyed it. Thank you.